Bismillahirrahmanirrahim. Hello, my dear students. I hope you are having a nice day. I welcome you all in class of O-level mathematics. Our discussion is continue on probability and combined events. Lastly, we discussed probability of an event for countable outcomes. In today's lecture, we will discuss some problems which are related to probability of an event with uncountable outcomes. So I am sharing some examples and exercise question from the book of New Syllabus Mathematics series. This is edition 8th edition. So related to this topic, in your book, you have a worked example to practice now to, and in exercise 2a, there are 3 questions 5, 6 and 17. In these questions, you will find probability of single event with uncountable outcomes. So in total lecture, we will discuss these 3 questions 5, 6 and 17. Question number 5 is on your screen. Firstly, you can read this question. Okay. In question, it is given that a survey is conducted to find out which of the 4 activities, soccer, basketball, chess and reading, students in a class prefer. The pie chart shown the result of the survey. There is a given pie chart here. In this pie chart, and this sector represent reading, and this is soccer, and this sector has central angle 135 degree. And this one is chess, which makes an angle 45 degree at center. And this is basketball, and this angle is given right angle. This is right angle, and this sector is basketball. You are asked, a student is selected at a random. Find the probability that the student prefers soccer. You can observe that in this question, the possible outcomes are uncountable because we have some proportional area, some sectors that represents the preference of students. Now, in this sector, that represents suppose reading. This sector has a infinite many points that cannot be countable. That's why this problem is related to this topic. Rather than in last lecture, you can easily count the number of outcomes in throw of single die or tossing of a coin. In tossing of a coin, there are only 2 possible outcomes, and in case of single die, there are 6 outcomes. But here you cannot observe the exact number of outcomes because in each sector there are the infinite many points in a sector. So in this question, you have to find the probability to, first is probability of soccer. A student, you have to choose a student at a random and find the probability that it prefers soccer. This is our question. You will write, suppose let S represents the event. Let S be the event. Let S be the events represent that student prefer soccer. So in this question, the probability of S, that is soccer is given by simply uh, angle angle of sector S means soccer divided by total angle in circle. Total angle in circle. This formula will be used. The denominator represent the total possible outcomes, that is actually represent the total angle in circle, and the numerator represent the favorable outcome for soccer, that represent the angle of sector of soccer. So the angle of sector of soccer is given by 135 degree here. 135 degree. So this is equal to 135 degree over total angle in circle. You know there are 360 degree angle in circle. So now cancelling numerator and denominator with 45, this becomes 3 over 8. So this is the answer of your first part. In the second part, you have to find the probability of reading. You have to choose a student reading. You will write let R be the event that represent the student prefer reading. So then probability of reading is the angle of sector angle of sector of reading divided by total angle. What is the angle made by reading? It can be visualized. It is easily visualized from the figure that the angle in this case is 90 degree, that is right angle. Otherwise, you can easily find as the angle at the center of circle is total angle 360 degree. Three of them is given. One is 45, second is 135, and this is also 90. Now plus you have to find this reading angle. Suppose this is x. Total angle in the center of circle is 360 degree. 45 plus 135, this is 180. 180 plus 90, this is 270. After subtracting, this becomes 45 degree. Sorry, this becomes 90 degree. 180, yes, exactly. Angle of sector for a reading is given by, this is given by 90 divided by 360, which is equal to 1 by 4. The last one is now you have to choose a student, and it will be it prefers basketball or chess. This is the case of or basketball or chess. Basketball or chess. In last lecture, I told you that in case of or, you will always you have to find the probability of union. This represent probability of basketball if basketball is represented by B or chess is represented by C. So this is the probability of B union C, which is given by simple probability of B plus probability of C. What is the probability of B? B basket. The number of students that prefer basketballs has the angle of sector 90 degree right angle. So this is 90 over 360 plus probability of chess. Chess is given by 45 degree, that we have already found now. This is 45 degree over 360 degree. So this is 1 by 4 and this is 1 by 8. And this becomes 8, 2 plus 1, this is 3 by 8. And this completes the question number 6. 5. Next, question number 6 is an interesting question of today's lecture. So let's discuss question number 6 now. Okay, next let us discuss question number 6. This is very nice and very interesting question. In this question, the question is on your screen. First, you can read this question. A spinner consists of a board in the shape of a regular octagon. This is octagon. An octagon, a polygon which has 8 vertices is called an octagon, regular octagon. This is the regular octagon with center O and a spinning pointer. Uh, this red arrow is a pointer, spinning pointer. The board is divided into 4 regions, P, Q, R, S. And the spinning pointer is spun at random. Find the probability that the spinning pointer will stop in the region S, region Q, region P or R. The difficulty in this question is that the central angle are not given, because to find the probability of such type of problems, firstly we need to find the central angle. So how can we find the central angle? There is a very easy method to find central angle. An angle is called central angle that we make at the center of the circle. So, for example, we need to find this central angle for region R. Similarly, we need to find this central angle for region S, this central angle for region P, and lastly, this central angle for region Q. So, you will write the central angle between any two consecutive vertices in regular octagon is given by the formula this is the formula is simple, 360 degree divided by 8. Why we are dividing by 8? Because in case of octagon there are 8 vertices, that's why we are dividing by 8. If your figure is hexagon, in case of hexagon there are 6 vertices, then in that case we will divide by 6. And this formula is special for regular polygons. In case of a regular polygon you cannot use this formula. This becomes 45 degree. This is 180 by 4, 90 by 2. Yes, this is 45 degree. So the central angle in each case between two consecutive vertices, like these are the two vertices of this polygon. So this angle is 45 degree. So you can say that central angle for region R is equal to 45 degree. Next, what is the central angle for region P? Central angle for region P is equal to, from the figure you can observe that the region P is 3 times the region S, because region P is the region that covers 1, 2, 3, 4. There are the 4 vertices covered by the region P. And you can also notice this as this is the first region, this is the second region, and this is third region. First, second, third. So P is enclosed by the 3 regions. That is 3 times of the region S. So that's why the central angle for region P is equal to 3 times 45 degree, which is equal to 135 degree. So this central angle is 135 degree. Similarly, now you can find easily the remaining central angle. In case of Q and R, both are the quadrilateral, and these are enclosed by 1, 2, 3. There are 3 vertices enclosed by 2 regions, this region 1 and this region 2. So the central angle for region R and Q is twice the region S. So the central angles for region Q and R is equal to 2 times 45 degree, which is equal to 90 degree. Now you can easily find the probability of each of the region. For example, probability of firstly you will write, let R be the events that represent the region R. Let R be the region. Let R be the. You have to find firstly the probability of region S. The question is that find the probability that the spinning pointer will stop in region S. You will write, let S be the event that shows the spinning pointer will stop in region S. So in that case, your probability for region S is simply equal to central angle for region S divided by total angle. Now the very important thing that you have to notice here, the total angle will be here angle in a circle, because always the angle formed at center is a circular. So that's why the angle formed by this pointer will be a circular angle. That's why the total angle will be 360 degree. These are not the total angle formed by the octagon, that is 1080 degree. So central angle for region S, what is the region S? What is the angle for central? The 45 total angle is 360 degree, and this is equal to 1 by 8. Next question is, you have to find uh, now pointer will stop in region Q. Region Q. Probability of Q. Firstly, you have to write, let Q be the event that represent your pointer stop in the region Q. So probability of Q is simply given by central angle for region Q. Region Q has the central angle equal to 90 degree. So this is 90 over 360 degree, which is simply 1 by 4. The third part is, now your pointer should stop in region P or R. Probability of region P or R, or mean union. So this is equal to probability of P plus probability of R. What is probability of P? The central angle formed by P is 135 degree. So it will be 135 degree out of 360 degree plus probability of R. Probability of R has a central angle 45 degree out of 360 degree. So this is equal to, sorry, I have done some mistake here. Actually central angle for region S, this is the central angle for region S. Now the central angle for R is 90 degree. So we have to write here 90. 90 over 360, this is 1 by 4. So this becomes 5 by 8. Now this is correct. Now next we discuss the last question, question number 17. Okay, next we discuss the last question of today's lecture. The question is on your screen. Firstly, you can read this question. Question says that ABCDEF is a regular hexagon with center O. Firstly, we make a regular hexagon. You know, hexagon has 6 sides. So this is my hexagon. And its name is A, B, C, D, E, F, and O is its center. This is its center. The next is M is the midpoint of AB. M is the midpoint of AB. This is the midpoint of AB. And N is the midpoint of BC. This is midpoint of BC, that is N. Next says a point is selected at a random in the regular hexagon. Find the probability that the point lies in the kite M, B, and O. If you join all of these vertices, all of these points, M, B, and O, this becomes a kite M, B, and O. You have to find, if we choose a point in this hexagon, what is the probability that that point lies in this portion, in this area. This is our requirement. The problem in this question is simple. You have to find this central angle. This is our requirement. Similarly, as previous question, central angle formed by two adjacent vertices in a regular hexagon is given by the formula 360 degree divided by total number of sides or total number of vertices in a hexagon, which are here 6. So this becomes 60 degree. So the central angle between any two vertices, adjacent vertices, is always 60 degree here. For example, if you join this with C, then now the central angle COB between these two consecutive vertices, this angle is 60 degree. This angle is 60 degree. As n is the midpoint of BC, so it will bisect the total angle. So there is a 30 degree here and 30 degree here. Similarly, if you join O with A, again the angle between these two vertices, this angle, this is also 60 degree. Now as M is the bisector of M is the midpoint of AB, so it will bisect the total angle. So this is also 30 degree and this is also 30 degree here. Left and right of M, both of the angle are 30 degree. Now you have to find this angle, this total angle. This is 30 degree and this is also 30 degree. So the angle between these two lines, M and N, at O, this is 30 plus 30, that is 60 degree. So angle MON, this is 30 plus 30, which is equal to 60 degrees. This is the central angle for sector MON. Hence, let A be the event that shows the point lies in the kite MBNO. This implies the probability of A is simply given by total angle, this is 360 degree, central angle, this is 60 degree, which is equal to 1 by 6. So there is only one chance out of 6 that your point lies in this quiet region. So this is the method in case when your outcomes are uncountable and you have such like of figures that involve angles to find the probability of some point lies in some regions. So I hope today lecture is very beneficial for you. If you find this lecture is helpful, kindly like, share, and motivate me. Inshallah, we will grow. I will complete, inshallah, your this complete book and other topics if you join me. So see you in the next lecture. Take care. Allah Hafiz.